talk about the Engrave Toolpath type. So we're going to start off real simple and then we'll create some toolpaths for a little bit more complex geometry. So to begin with, I'm just going to draw a rectangle, and that'll serve as our geometry to begin with. And when we talk about the Engrave Toolpath, we're really kind of talking about two different types of toolpaths. The first one is what we refer to as a 2D engrave, meaning that essentially the tool is applied directly to the geometry, whatever the geometry is. So I'm gonna choose a conic tool, and one thing that's true about 2D engrave is you can use any kind of tool that you want to, and since it's being applied directly to the geometry, the type of tool that you select really doesn't make any difference to the type of toolpath that gets created. And so for sort of illustration purposes, I'm going to choose a 90-degree conic here, and I'm going to give it a depth of I'll give it a depth of 0.3 inches. Click apply. Now what you see, of course, is that the toolpath basically is right on top of the geometry, and if we look at the perspective view, you can see the toolpath is down that 0.3 inches and is essentially just right on top of the toolpath. So let's simulate this, and I'm going to draw a rectangle that we'll use to sort of define where we want to simulate, and click OK, and let's simulate it real quick. And when we turn it on here, you see that I've got the toolpath, since it went right on top of the contour, the center line, the low point of the simulation here, that's the size of the box. And so that's a kind of a key thing, is where do you want the toolpath to go, where do you want the bevel in this case to go with real simple geometry. So that's a 2D toolpath. If I come back here and say that I'm going to do essentially the same thing, and we'll come in and edit the toolpath, and I'm going to go what I know is deeper than the width of the tool, meaning that the EnRoute will enforce the need to go to 2 passes. So when I click OK, and let's look at it in the perspective view, you see that I've got 2 toolpaths, 2 passes. So I come back here and let's simulate this again. Okay, so there you can see that the simulation shows what I wanted to show, is that the geometry of the tool then sort of enters into the thing, because I've gone past the cutting depth of the beveled part of the cutting depth of the tool, and so I'm going to be cutting vertically down once I go past that, and that's essentially what the finished part will look like if I go ahead and cut it, assuming that the tool geometry that I have defined matches the actual geometry of the tool. So that's a 2D engrave, and there's lots of good uses for a 2D engrave. I can go around artwork with a conic tool or an engraving tool or a end mill tool and get results that can be quite pleasant or useful or whatever, but what doesn't happen is that the toolpath is not adjusted depending on the shape of the tool or depending on the geometry. It literally follows the geometry. So now let's clear that toolpath away and do the same thing, and I'm going to go back down to something that I know is less than the cutting depth of the tool I have defined, and I'm going to change this by going 3D engrave. So everything is the same, and I'm going to go internal. So once I do a 3D engrave, then I have the option of going internal or external, meaning that the toolpath will go inside or outside of the container that I have selected. So I click OK, and now what you see is that the toolpath goes to the inside of the geometry, and it goes down to create sharp corners, and that's not going straight down, it's going down at an angle that's appropriate for the geometry of the tool. In this case it would go down at a 45-degree angle because that's the bevel angle of the tool that I'm using. Now it's relatively simple. It's quite simple actually for this type of geometry, but here in just a minute we'll go to more complex geometry, and you'll see that the results are quite a bit more complex. Okay, so if I click OK and I do it, you can see that now my end result looks pretty similar to what I did originally, except that now the outer edge of the bevel here is what represents the geometry. And if I continue to go down, that's where you'll see quite a difference compared to the two passes that I did before. So let's step back, and I'm going to come in and edit this geometry, and let's do the same thing. Let's go up to 0.9, and as you know, I'll go to two passes for that cut. If I click OK, so now what happens in the second pass is it goes in from the first pass based on the tool geometry, so it's 3D, so it keeps going down inside at that same angle. And so now if I simulate it, you'll see that I'm about to get to the bottom of the geometry there. It still bevels back up where I haven't cut it yet, but I'm getting closer to the bottom of the geometry. Okay, so we've sort of introduced the subject here, and now what we want to do is we want to do something a little more complex. So I'm going to get rid of all of this, and I'm going to bring in a bitmap. So let's bring in a bitmap here. Okay, so let's bring this in as a bitmap. We're going to vectorize it real quick. So now we've got some geometry that's a little bit more interesting. Okay, so we're going to take that same Engrave Toolpath and let's drop it back down to one pass. It's a 3D engrave. Now you see that in a lot of cases my toolpath goes right to the center of the geometry. Here it doesn't go all the way to the center just because the depth is the limiting factor there. So if I want to get that to go all the way to the center, I'm going to need to go deeper. So let's edit that and let's go deeper. Now it's going to require two passes. So the first pass will do what it did initially, and then the second pass will go all the way to the bottom. The nice thing is that this is quite a complex toolpath, and EnRoute takes care of all of the work, all of the calculations to create it. So now we're going to simulate it. There you can see we can get just a really nice result with a 3D engrave with you know, just a few clicks really. If I'd have started from the beginning with this, in this case I created the geometry by importing a bitmap and vectorizing it, but if I already had geometry, if I had some other type of geometry I wanted to use, it's just a matter of selecting the tool and the depth, taking into account the cutting parameters of the tool, and I can create really quite a nice effect with the 3D engrave. The 2D engrave once again would follow the geometry, so it would look decent, but it wouldn't have this refined finished look that the 3D toolpath does. Now real quickly, if I want to, it's also real possible to come in here, and I'm going to edit this toolpath again, and I'm going to change it from internal to external, and let's just see what we get. And I'm also going to reduce the depth down to a single pass. Oop, I'm still at a double pass. So let's go back here and go to a single pass. There we go. Now increase the size of my simulation rectangle here. Okay. So there you see the geometry. My original geometry serves as the interior, and those beveled tool paths went to the outside. So that's an external 3D engrave. Does essentially the same thing, it just goes to the outside instead of to the inside. But you can see that it finds the center between whatever geometry is appropriate, and that's where the toolpath goes, and then goes up into the corners sharply to create a really pleasing effect. So that's engrave. We've looked at 2D engrave, 3D engrave, both external and internal, with multiple passes and single passes, taking into account the geometry of the tool. So thanks, and we'll talk again.